Hendra is a genus of RNA virus, with 5 known species of this virus housing themselves within the bodies of many species of flying foxes and microbats. The most commonly known species of hendra within the equine industry is hendra or again more commonly known as hendra virus. It was first discovered in Australia in 1994 in a training complex within a Brisbane suburb called Hendra. The transmission of hendra virus from bats to horses stems from the horse's exposure to fecal matter and bodily fluids that are excreted by infected flying foxes. In 2008, a study in Geelong, Victoria was undertaken to obtain a better understanding of the risk of transmission posed by horses at various times during active hendra virus infection and permit incorporation of recommendations to reduce the transmission risk to humans and other horses into outbreak management strategies. The study was conducted on 3 mares which housed in individual stalls in one biosafe room to provide a controlled environment. Observation of the horses were made twice daily. These included respiratory, heart rate and rectal temperatures, as well as the biological samples including nasal, oral and rectal swabs, specimens and blood. Figure 2 indicates the rectal temps and heart rate of the 3 horses over the 9-day period, and it can be seen in Figure 2 that all 3 horses displayed a somewhat similar trend by displaying no signs of distress for the first 5 to 7 days depending on the horse. After such time, each horse recorded a parallel increase of both rectal temps and heart rate as their health began to deteriorate and displayed depressive behaviour as well as flu-like symptoms, including nasal secretions. Data that was collected indicate that nasal secretions could lead to the risk of transmission of the virus from infected animals to veterinarians and animal handlers during the early phases of the hendra virus. Although the exposure of nasal secretion has the potential to lead to the transfer of the virus, horses with a longer exposure to the virus displaying more symptoms are more likely to pose a greater risk of transmission by not only the exposure of nasal secretions, but the excretions of urine and blood as well, much like the original transfer from the flying fox to the horse. As the length of exposure of the virus increases, so does its ability to be transferred to the unaffected host, such as the veterinarian and animal handler. As a result, making post-mortems of an infected animal a highest risk of exposure. It can be seen in Figure 6 the abundance of hendra virus within different parts of an infected horse during post-mortem. Finally, the data recorded indicates that the most crucial time to reduce the transmission of hendra virus is to identify hendra virus as a potential reason as to why the horse might be showing flu-like symptoms, thus implicating the correct management strategy until such time that a conclusive diagnosis on the causes of the symptoms have been made.